Alright, so now that we have planned out our entire wireless LAN network and gone over the switch configuration, let's jump into the wireless LAN controller initial configuration. So, sorry, again, if you're watching these videos not in order, you're coming off the internet, straight into this video, my name is Johnny Bandon. I'm the CCNA instructor for this CCNA video series delivered by Intrepid Technologies. And in this video, we're going to go over initial configuration of an actual wireless LAN controller. So my hardware I have is going to be a 2504, which is this wireless LAN controller here. That's what I'm going to actually console into and do the initial configuration. However, you have to be aware of these more robust wireless LAN controllers because they are going to have more ports, like a redundancy port and a service port that we're going to cover here in these sections before we jump into the CLI. Okay, so with that being said, let's go over what a redundant port is. So this port is reserved when two wireless LAN controllers, hardware appliances, are participating in high availability and stateful switchover. I think that's what SSO stands for, or stateful failover, something like that. Essentially, we have our hot and standby wireless LAN controllers. So this is going to be the port that you connect both these wireless LAN controllers on. So we know from our earlier sections, high availability, that's when two wireless LAN controllers are connected via their redundant port. And then we're going to have an active and backup, but the terms are hot and standby. And both are going to keep and contain that active list of all the CAPWAP connections and all the APs that are associated, so that if the hot goes down, the standby takes over. And then we have our distribution system ports. So these are just going to be these ports you see right here that are actually part of the management network. And this is going to make more sense when we actually get into the CLI configuration. The management network is the VLAN, the IP addressing that you put on the actual wireless LAN controller that you're going to use to GUI into this in-band. And what I mean by in-band is when we go over the service port, we're going to talk about out-of-band management. But essentially, these management ports are going to be what we use to connect to our distributed system. They connect to that core, that distribution layer switch. Typically, you're going to see maybe even like lag be performed, which is link aggregation. So port channeling between like a wireless LAN controller and the distributed system. Oh, so I kind of skipped ahead. Sorry about that. I was like, wait, we're supposed to go over service ports. So now we're going to go over the service port. So the service port is going to be a dedicated management port. And this is so confusing because we have our distributed system ports that are for our management network. However, the service port is our dedicated management port for out-of-band management, meaning that no data traffic, there are CAPWAP tunnels, nothing's going to be built over this service port. This is just used as a separate subnet that we can use to also GUI in and manage this wireless LAN controller. So for instance, we could maybe put this like on a virtual route forwarding instance and make this part of a management network that's only used internally, right? For our out-of-band management network. Or this could be for external use as well. We could maybe create this service port to be routable out to the ISP by maybe doing some port forwarding connections. And when we're at our house, if we don't want to VPN in, maybe we can use that service ports configuration. We have to do that with some static routes and more configuration on a distributed system. But essentially for the test, this is a out-of-band management port, and it's dedicated strictly for management. It's still going to connect again to our access ports on our switches, but it's going to be part of an entirely different broadcast domain than the actual management network. And then we have our console port, which, I mean, what's there really to explain here? This is the same as a console port on any iOS device. It lets you access the CLI. Okay, so now moving on to the wireless LAN controller initial configuration. So I'm going to go over the actual CLI initial configuration of our wireless LAN controller. So this is under the assumption that maybe we didn't get this wireless LAN controller out from straight from the factory, and there may be configuration already on there. So I'm going to show you how to clear any configuration previously saved on that wireless LAN controller. And we do that by hitting the escape button, which is going to access the boot menu. And we're going to go through these slides and then do it in real time. And then you see it goes to our bootloader menu. And if there was a previous configuration, we're going to clear it by hitting 4 and then hit enter. And then it's going to bring us to our actual CLI configuration. So it's going to ask us, would you like to terminate auto install? We're going to hit yes. And then we're going to get into actually doing the initial setup of our wireless LAN controller. So the first thing it's going to ask us is for the name. What is a wireless LAN controller name? So you see this like message kind of interrupted it, but I named it my WLC. And then we're going to do just, typical admin stuff. Set a username and password. Password does have requirements on it. I noticed that it has to be 8 characters long. If you try to do anything less, it's going to give you an error. And then we're going to set up our management network. So again, this is not that service port. This is going to be the distributed system ports, which are the connections for the management network of the wireless LAN controller. So this is going to be simple. What's the IP address? What's the subnet mask? And the default gateway, again, that in our environment, that's going to be SVI 10 on this layer 3 switch. And then it's asking us if we have a VLAN identifier. So this is what I was talking about earlier, where I said that this wireless LAN controller here, it's, even though it's connected via a trunk port, we're still tagging traffic leaving it with VLAN 10. So that's why that trunk port, we changed the native VLAN to native VLAN 10 so they can communicate properly. And then we're going to decide, okay, which management interface port is going to be actually doing this data traffic. So if we were setting up lag, we would get a different option here. I think for this wireless LAN controller, this is where I took the screenshots. It doesn't let you do this in the initial CLI configuration, but you can in other wireless access points. Wireless LAN controllers. So, I'm just using interface 1, so I put 1 right there. And then our management interface, DHCP server IP, that's also just going to be our default gateway, right? That's where our DHCP server lives. If our DHCP server lives somewhere else, you'd put that different IP address. And then after this, if we were on a different wireless LAN controller with a service port, redundancy ports, this is where we'd put, the next option would be like service port IP address. And again, this has to be different from the management network because that's that dedicated out-of-band management port that doesn't do any data traffic or any CAPWAP connections, right? All right, the next on this 2504 wireless LAN controller, we're going to set the virtual gateway IP address. And what this is that in a very large deployment, when we're creating CAPWAP tunnels to maybe 2 or 3 WLCs in a high availability cluster, we can kind of do almost like HSRP or our first hop redundancy protocols, where the wireless LAN controllers share this virtual gateway IP and the access points make connections there instead. And that's how we kind of keep the standby wireless LAN controllers in our high availability clusters with those active CAPWAP tunnels as well, or at least a table of active CAPWAP and associated access points. And then we have our mobility RF group name. This has to do when we do like roaming and stuff. Not going to get into this in the CCNA exam. Just know that if you want a mobility group later on, you can give it the name right now. And then our first SSID that we're going to create, that's going to just give it a name, Trepatech. We can get into the GUI later and disable and change these settings. Then it's going to ask us, do we want to configure DHCP bridging mode? So this is where the WLC will actually be the DHCP server as well. We're going to set no on that. I think that's what DHCP bridging means. I'll put in the description if I was wrong, or maybe I'll edit it out. But I'm pretty sure that's where the WLC either is the DHCP server or is going to like kind of bridge those DHCP door connections. And let's just go ahead and take a pause here and look that up. So give me 1 second. Let's exit out of here. We'll type in DHCP bridging mode. Okay, so essentially this just makes it a DHCP helper. Okay, awesome. So DHCP bridging mode provides an option to make controllers, roles, and DHCP transactions entirely transparent to the wireless clients. So essentially this just makes it kind of like that relay agent. So we're going to put no on there because we don't need the wireless LAN controller to be that relay agent for us. All right, cool. Sometimes, you see instructors sometimes kind of bullshit their way through it. So I'm glad we took a pause and looked it up because we want to be putting out the right information, right? And then it says allow static IP addresses. Yes, we're going to want to allow that, right? We're going to want to set static IP addresses on our wireless network and on our wired connections as well. Configure radius server now. So this is a good idea, and we should configure a radius server, especially if you want to do enterprise mode on our security, where we have some NAC or 802.1x. But right now, that's not what we're doing. So we're just going to put no because we don't have any radius server to configure. And again, that country code. So you see here, I just left this in brackets here because we're going to be in the US. So if I just hit enter here, it's just going to input whatever in those brackets. And here you see these brackets, guys, whatever is capitalized, if I just hit enter, that's the selection it would make. So I didn't have to type no and yes here. I thought it just looked better like on these screen clips I got. And then here you just see I kept hitting enter, enter, enter because I want to enable all the different frequency ranges and radios and enable auto RF. And then here it says configure NTP server, which we need, right? We need our timing synced. I'm going to say yes. And then I just made the switch, the interface VLAN 10 IP address as the NTP server IP. And then it says enter a polling interval between 3600 and 604,800. That's for NTP, just 3600. And then that's it. There's your initial configuration. And then we're just going to go ahead and reset that system. So here, we will actually have to put yes here because if we just hit enter, it's going to say no. And then once it reboots and we have that configuration, we can log in and run some simple show commands. Show interface summary. We can see here no service port. And then we can see some licensing, stuff like that. And then after that, now we can start getting into the GUI. So I'm going to go ahead and pause this video here. I am going to console into my wireless LAN controller, going to power it up, and I'm going to show you exactly what that looks like. Okay, so I'm plugged into the console port from my laptop into the actual WLC. And why would I see here, press escape now to access the boot menu? I'm going to do that because if I'm doing the initial configuration, I'm just going to clear anything. I don't even want to run through and say, oh, let me check to see if there is configuration. Nope. We're just going to get into that bootloader menu, kind of like getting into Rahman mode of an iOS when you're doing like password recovery. And we're going to go ahead and hit 4 and hit enter. And we're going to clear the configuration. And now it's going to go through its reboot process. For this 2504, the one I have, it's actually pretty quick, but I am just going to go ahead and pause that video and then start again when we actually get to the initial configuration steps where it says terminate auto install. So let me go ahead and pause it and then we'll be right back. Okay, we're back. So again, we're going to get to this initial screen that says, would you like to terminate auto install? I'm just going to hit enter here because we want to do yes. And it's in the brackets, right? So that means if we hit enter, it's just going to take that as a yes, right? Or whatever in the brackets. So here we got to name it. So we're going to name it again, my WLC. We're going to give it a username. So we're just going to keep it simple, Cisco. And then I'm just going to do my password that I do for all my labs, which is on the keyboard, 1 down, shift 1 down. And then we're going to do our management interface IP address. So again, if we look back on our network diagram, that's going to be the 192.168.10.100 the actual IP address of this WLC. We're going to give it a /24 subnet mask. The default router is going to be interface VLAN 10 on that layer 3 switch. Then it's in VLAN 10. And I'm currently plugged in from wireless LAN controller to the switch on port 1. And then the DHCP server is also just going to sit at that layer 3 switch. So I'm going to put, again, the IP address of interface VLAN 10. Then the virtual gateway IP address. I'm just going to make one up here because in this lab, we're not going to do any high availability where the access points are going to connect to this virtual gateway IP. So just make one up here. Mobility RF group name is also not going to be part of this demonstration. So we're just going to give it Trepatech. Then the first network name we're going to do is going to be my SSID. Again, it's just lab. So configure DHCP bridging mode, which again, this is kind of just like that relay agent. We're going to hit enter for no. Allow static IP addresses. We're going to hit enter for yes. And then we're not going to configure radius server now because we don't have one set up. We're in the US. Then we're going to hit enter, 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 enter because we do want to enable all those radio channels. We do want to configure an NTP server, and that's going to also sit at our default gateway, that layer 3 switch. Then we can just do 3600 for the polling intervals. And then, yes, we do want to save it and reset it. So now it's going to go through another boot process. So I'm going to pause the video again. And when this comes up, we're going to log in, do some basic show commands, and then we're going to access the GUI for the first time. Okay, so now that that wireless LAN controller has restarted, we're at our login screen here. And now we just got to log in just like we would on a regular iOS device. And from here, we do have some commands we can run, like show interface summary. But now the real purpose of getting this initial configuration done via CLI is now so that we can access it via the GUI. And I wanted to go over something, guys, that I'm going to have to edit out in my previous videos. That for this deployment, where we have an actual wireless LAN controller appliance and a physical switch, I said earlier in the videos that our trunk port would have to have switch port trunk native VLAN 10 on it. That's actually not true. What I was thinking about is our EVNG lab. That is a command you have to run. But to get this working, and I have to go back and edit the previous videos, you don't need switch port trunk native VLAN 10 on here. Because the wireless LAN controller is already tagging, the switch is going to receive the frames from the wireless LAN controller already with that 802.1q tag that this trunk is going to pass on. In the EVNG lab that we run, where we have a virtual wireless LAN controller, virtually an EVNG, but still actually controlling access points physically in the real world, you will need that command on the switch connected to the server that's running ESXi, which is running EVNG, but not for this deployment. So it's my fault, and the other videos I have to go back and edit. Just wanted to let you know that if you're following along, that the trunk port, you actually don't need that switch port trunk native VLAN 10 command. You don't need that. Okay? So now we got that out of the way. Actually, let's just minimize this. Let's go ahead and access this via the GUI. So what I'm going to do here from my computer is just make sure that we do have IP reachability. And we do. So we can ping the wireless LAN controller. And now let's actually access the GUI. So what we're going to do now is open up a new tab in incognito mode. And we're going to just type in the IP address of our wireless LAN controller. Let's see here if we can do HTTPS. Let's see if we can do HTTP. So what we might have to do here, and this is good, this is some troubleshooting, is let me console back into my wireless LAN controller. And we're going to have to enable the web server. So I believe it's like web. Let's see. No, so secure. Let's look it up real quick. Enable. Yeah, I've had to do this before. you're going to have to enable the web mode, and this is a CLI command we can run. Let's go ahead and see if we can look that up. Come down here. We need to find where the CLI is. Not SSH connections. Let's see here. We can just look it up. HTTP. There we go. Enabling web and secure web modes. Okay, so it's going to be configure, network, web mode, enable. So it's going to be config, network, web mode, enable. Then should be config, network, and then what's the secure mode? So secure mode is how we're going to do HTTPS. Enable. And then we'll have to reboot for the changes to take effect. But let's just see if we can get to it via HTTP here. And we can. Awesome. So we probably have to reboot for HTTPS to work because it's got to like build a certificate. But now we just sign in. And here we are, guys. Now we're at the wireless LAN controller GUI. So if we come back to our slides here, what we want to do is enable the license first. And then we're going to be done with our initial configuration. So let's go back to this presentation here. So now that we've accessed the web GUI, and kind of cool, we kind of saw some troubleshooting, right? If we can't access it for some reason, we can ping. Let's make sure that the actual HTTP service is running on it. So you got to see some real troubleshooting. So now we're going to enable the license. That's going to be the first thing we're going to do. So how we do that is we're going to go to the management tab. We're going to click licenses right there. And once we do that, we're going to go to our licenses here. And we're going to click in here and pretty much just make one of these two active. So this one we have AP count with 200. We're going to make sure it's active and in use. And then once we click in there, we're going to set the status. And then once we do that, we'll hit save. That it's not in this screen capture right now, but it's real simple. So let's go ahead and do it. So we're going to come over here to management, software activation, licenses. We're going to go into, let's do this base AP count right here. We're going to set, let's do high priority. We're going to accept that license term and agreements. So it says we have to reboot the controller to make this change take effect. But now you can see that this one's in use. So it's kind of different from the screen clip in that I probably had a different wireless LAN controller in that screen clip, probably my virtual WLC. But you can see here, we had to set the priority and then that set it to in use. And then before this can actually work, we have to hit save. And then we have to reboot the actual wireless LAN controller. So pretty sure we could come back here to management, maybe commands. There we go. And we can hit reboot. So we're going to reboot this WLC. And then if we really wanted to make sure, we could just go over there and unplug it, plug it back in, right? But now that WLC is going to be ready to actually have access points connect to it. Okay, so we're going to go ahead and stop the video here. In the next section, we're going to go over actually deploying the wireless LAN. So we're actually going to go through and make sure that our AP is connecting to our wireless LAN controller. We're going to name the access point, set the mode on the access point. We're going to create that logical interface, right? This is going to be our VLAN to SSID mapping. And then we're going to actually create the new wireless LAN. And then we're going to connect the user and test. So here I'd like to actually probably just have my iPhone connect. And then see if we can just do a ping test, right? And then, or really just probably just have the client connect. And then that'll be it. If we even get that far, because I kind of want to save that for the actual lab. With the demonstration, this is kind of just very methodical. So we'll probably go through these 4 steps. And then this last step we'll probably just save for our actual lab. But okay, so join us in our next video.